Welcome to the last edition of Common Algebra for Chapter 10. This is graphing the tangent. Now, sine and cosine, we saw, are continuous graphs, meaning we don't have to pick up our pencil to graph the whole thing. Tangent, however, is very different. And we have seen in the unit circle that sometimes tangent, when it hits a quadrant angle, the denominator could be 0. And we learned in Chapter 9 that wherever the denominator is 0, we have points of discontinuity. In other words, the graph does not exist. So this happens quite often in tangents, so we're going to have lots and lots of asymptotes. All right, in our example, we are asked to graph 3 cycles of tangent theta. So you can enter tangent x in your calc, and maybe before you do that, check what is the tangent of negative 90 right here. And if you enter that, you should get an error message because it doesn't exist there. Likewise, the tangent of 90 doesn't exist, so I've drawn an asymptote line. Tangent 270 doesn't exist. And tangent of 5 pi over 2 also does not exist. So these are asymptotes. And now if we were to graph like the tangent of 0, if you type that in, you would get 0. If you type in tangent of 180, it's 0, and tangent of 360, it's 0. And if we wanted to do some in-between degrees, for instance, the tangent of negative 45 would give us a negative value here. And in class, we spent time and we plotted these points so that the tangent graph looks something like this. Likewise here, if we graphed points on either side of the 180, it would come up and cross at 0 and keep getting higher and higher and lower. And likewise, if we plotted points on either side of the 360. So there we have graphed 3 cycles of the tangent. Now we're asked to list some different things. They want us to state the asymptotes, period, amplitude, and we'll also do domain and range. The asymptotes here, and maybe you can see if we have the positive asymptote, we're going to also have to list the negative asymptote because this graph keeps going in both directions forever. So to state the asymptotes, we're going to use the plus minus approach. So first, the first asymptote we see, if we're starting at 0 and look at either side, we have plus minus pi over 2. Next asymptote is out here, plus minus 3 pi over 2, plus minus 5 pi over 2. I think 3 is enough to establish a pattern, so we'll just then put our 3 dots and say, and so on. So this could be a logical time to go down here and state the domain of this tangent. Because the domain, you can see it exists everywhere except at the asymptotes. So we will state the domain as the set of all x's such that x is not equal to our asymptotes. So I'm just going to repeat the same list here because this is where x does not exist. If we want to do the range at the same time, because we're kind of in domain and range, looking up here, it goes up forever and goes down forever. So there is no limit on the range. The range is all real numbers. All right, let's back up, and we need to do period and amplitude. So the period is sort of obvious. It's where does this repeat? Well, if I just picked up this entire first piece here, picked it up, it repeats here, it repeats here. So the repeat goes from this negative pi over 2 to pi over 2 And so how wide is this across here? Well, pi over 2 plus pi over 2 is pi. So the period of the tangent is pi. And the amplitude, well, how do we do half the height if it's going on for infinity? We just say none. There is no amplitude. So once again, I recommend leaving the tangent function in as the parent, and then to do the different transformations, you can graph them in your y2 or y3 locations and compare them. And that should help you with your assignment. All right, have fun.